we say everything is made from stardust, and this stardust comes out of these nebulas. And nebulas, we don't even know what it is. We don't even know what a nebula is. We say nebulas are scarce in the universe, but they're the cause of everything in the universe. So nebulas, if you actually look at them and pay attention to what they look like, they literally look like a wormhole that is a breakthrough between two parallel dimensions. You see, in space, it appears, aesthetically speaking at least, that a nebula is this gaseous structure, ambiguous gaseous structure around this difference in contrast between the same spatial extension. So the same spatial extension, on one side is dark and on one side is more light. Okay? And out of this light, you say, well, objects come into being into our, dark, space, into our space. You see stars come into being from these nebulas. Okay? And you're like, whoa, it's almost like a hub for making stars, like a generational point. And it is. That's exactly what it is. It's just like the nerve ending in a neural structure in the brain. The nerve ending of that, where photons are being shot out. They just appear out into being and go to another neuron, into a different, wormhole dimension. And so what we're seeing is just a very nerve ending, let's say, in a nebula, when we're looking at a nebula. Things coming out of a different dimension. But it's also equal to what we mean by things coming into being in general. So it's confusing. This nebula is this wormhole or dimension between two parallel dimensions, and it's ultimately their intersecting point. But their intersecting point isn't a difference in their parallelism, or rather a difference in their shape, physical shape. They both remain parallel, but their interaction is that in between them, they generate phenomena and experience. They generate something that's particular, like a star, and then a star generates something like a planet. And this is a deep cosmological layout and structure of the universe I'm trying to explain. And so it's not just fantasy or fancy as the moderns used to say. It's an actual analysis of what the cosmological structure of the universe really could be, and we're on to that. I already see videos like, is the universe a mind? You know what I mean? Is the universe a mind? But the point is look at it. You have nebulas, okay? And they're this point, discrete point between two parallel dimensions that a discernible level of quality is being entered into the scene. And so we say, okay, well, where are black holes then? We say, well, black holes are in the universe, and we say there are different magnitudes of black holes. There's like a supermassive black hole, and that there are smaller black holes, okay, that our universes rotate around, the more concentrated form of galaxies. And then there are like huge massive black holes that we don't really know what's on the event horizon of that. And so it appears, if you observe the universe, that the universe is littered with a bunch of different black holes, and in between those, they're the universe, the actual content of the world, planets, stars, whatever. This is an abstraction of the universe. It's a limited conception of what it actually is. Obviously it is. I mean, anything we look at is a limited conception to some degree of what the thing really is. And I can look at a leaf and I zoom deep into that, and I find molecules and different parts that make it out, as the microscopic conception denotes. But why is that a limited conception of the world? Why is it a limited conception? It's a limited conception because the only way we can come to observe a black hole is what's called through the phenomena of gravitational lensing, where a black hole more distant away from a galaxy or a cluster of stars distorts the light of these clusters and stars around its event horizon. And so we know it's a black hole is behind these things, but we just don't see the black hole because the phenomena or the clusters of stars and the objects are always in front of it. It's always where our vision point of view is. So we can't see behind the thing that you're looking at that blocks the thing you're trying to see, which is the black hole. You can't see the black hole because you can't see behind the galaxies. You only see them being really distorted in a freaking weird way. Like clearly a galaxy cannot look like that. It's like straight. It looks like it's a noodle. It's like, well, obviously that's not what a galaxy is. There's something that's distorting the light. That the photons that come to my eye is holding wrong information. And the thing is this. There is not many different black holes in the universe that are different in size. Because if we measure a black hole by its size, that doesn't tell us first what a black hole is in nature, and second what its form is, because its form is always spherical no matter what size it is. And there are different sizes of black holes that vary in great extent. There's like a huge supermassive black hole, and then there's an infinitely minute small black hole, which is called Schwarzschild radius. The 0 point energy in every object. If you take the total mass of any object and reduce it to the smallest possible space within it, that smallest space within it can contain the total amount of the matter that makes up the actual object. And so if you take all my bones and meat and just crush it into, an analogy, obviously, an imagery analogy, and crush it into that small space, it could fit. And that little void space is in you. You see, if we look at it purely spatially, it looks like just a small space in you, which is wrong. But if we look at it spatially extended, or also temporally, apply the element of time to it, that it's a full extended duration, then we can say, well, that little minute space is infinitely long. It's infinitely durated outward or inwards, or whatever you want to say. It's infinitely going. And so now it makes sense that my entire matter fits into it, because I could just make me like a string. And that's what string theory ultimately concludes, is that objects, when they enter into these, most fundamental components of the universe, like beyond the atoms, the quarks, and beyond those, we find these string-like phenomena or objects. And these string phenomena are not really objects, they're actually dimensions, which objects tend into. And so black holes are exactly the same phenomena, but seen in the most macro scale, and the greatest extent of the universe. And what we see in a black hole are not different black holes. We're not seeing different black holes, one small, one big. We're just seeing the phenomena relative to the size of the actual object that we can directly observe. We see a black hole in contrast to the size of the galaxy, and therefore it looks small if the galaxy is small, and if it looks big if the cluster of galaxies is itself huge. Because again, gravitational lensing is the light of the object and the stars or clusters of stars around the event horizon of the black hole. So it isn't the event horizon of the black hole that's huge, and then you have like a small tiny galaxy in it. That doesn't make any sense, because you won't be able to see the light reflection. You need more light, so you need the clusters of a lot of galaxies, and all their lights combined forms the extent of the event horizon. And so there's not many different black holes all scattered around the universe. There's one black hole, one huge massive black hole. In fact, the universe itself is in a huge black hole, falling into that black hole, or rather going in a outwards duration whose end point is the furthest possible point away from the observer, no matter where the observer is situated in this plane field, in this environment. This is called the cosmological principle, that the observer is always the center point of a sphere. Any point you choose on the surface of a sphere is its center point. You see? Any point. Choose any point on a sphere. It's always its center point. And the universe is always inherently a sphere because, as we said, from the interaction of black holes and galaxies, is that you have what you see, which is the cluster in front of you, and then there's always that thing that it's blocking, the thing behind it, the thing behind your head, as the Buddhists and the Alan Watts and all the, aesthetical philosophers, the phenomenological say. The thing always behind your head. Wherever you turn, there's always a thing out of sight. The thing that escapes your vision and also escapes your conception, your mental vision. Like to even conceive it, you can't. It's behind your conception. You see, and that's a very deep claim in and of itself. Probably the deepest one. But apply that to the universe, and the black hole, the universe is just this substratum, this matter, a lot of matter, this substrate that's taking on an infinite number of qualities, and these infinite number of qualities look like little lights from a star, but once you zoom in close, you realize that these so-called stars may not be stars at all. They might be nebulas. Fundamentally they are, because stars are a result of nebulas. And so you have all these things that look like stars, but are actually all nebulas. And there are all these passageways between two parallel dimensions. And their third dimension is their interacting point, that intersecting point where a thing comes out of a nebula into being, a star per se out of the star dust of a nebula. And we say, okay, well that's what brings things into generation in the universe. But how do things end up? What happens when they die? And what we notice in a star is that when it dies, it turns into a black hole. The black hole is always at the end of the lifespan of the stars. We say, well, some stars result in a black hole and some don't. But again, that's a problem with our observational methods. Our perception is limited. We see some, the bigger ones, or maybe the ones that have a good reflection of light in relation to our point of view. We see those as resulting in a black hole because we can see the light escape into the event horizon. And some we say we don't see that, but that doesn't mean it's not happening. In fact, all stars end up as a black hole or turn into a black hole, as we say, is because they're being extended within a black hole. They're being extended in a black hole. They're being taken out by an infinitely dense, we say, condensed point. An infinitely condensed point. It's being stretched out like a string, and it's being passed through to the other side. The other side, however, is the very same size that you see the generation of things come into being. And therefore it is the nebula, as you say, but nebula is only a particular abstraction of something more fundamental than it, known as a white hole. Stuff are always emerging out of a white hole, but we never see a white hole in space. We see black holes, but we never see a white hole. We don't see where things come into being. But guess what we say about the very first instance of the universe? The most common explanation to how our universe originates. Come on, take a wild guess. The Big Bang Theory. The Big Bang Theory has at the very beginning of the universe a massive light show explosion. You know what I mean? It has this point that's just infinite light. In Islam, actually, they call it Nur, which is the essence of God itself. It's this pure light, this essential light. This light that's always giving, that's always light. It never dies out, it never shuts off, you know what I mean? A star, like our sun, is a mimicking of that. It's a particular limited energy assimilation of that. It's a demonstration of that in a finite sense of time. And so the sun, if you look at the sun, it always looks like stuff is coming out of it infinitely, like infinite light is coming out of it. But we say, well, that burns out over time. And guess what happens to it? It goes into a black hole. So it just goes away further from the observer into a black hole, and therefore it dims out. But it never dims out. It's just reflecting from the other side.